So we are given n cities numbered 0 to n minus 1 and n minus 1 roads such that there is only one way to travel between two different cities. This network form a tree. Last year, the Ministry of Transport decided to orient the roads in one direction because they are too narrow. So this is one-way roads, okay? Like it can't be two-way roads. Roads are represented by connections, where connection I is AI, comma BI, represented a road from city AI to city BI. So let's suppose we have a city A and city B. Like there can be only a one-way road between them. So we can go from city A to city B, but we can't come back from B to A. This year there will be a big event in the capital city Zero. So there is a city named Zero, and there will be an event in that city, and many people want to travel to this city. Your task consists of reorienting some roads such that each city can visit the city Zero. Return the maximum number of edges change. It is guaranteed that each city can reach city Zero after reorder. So ignore these red arrows, okay? These are the arrows that we have to change. We'll come to this later. Just focus on the black content in this figure. So we are given how many cities? 0, 1, 2, 3, 4, 5. So there are five cities in total, okay? And we are given the connections. 0 city is connected to 1, and 1 city is connected to 3, 2 is connected to 3, 4 is connected to 0, and 4 is connected to 5. What does this mean? It means we can go from 0 city to 1 city, and from 1 city which is named 1 we can go to city 3, and from 2 we can go to 3, and there is only one way road. So if we are going from city 0 to 0 1, there is no way coming back. Like we can't come back from city 1 to city 0 because this is one way road. Similarly, we can go from city B city 4 to 0, 4 to 5. Now we have our task is to make it possible that every city can travel to city 0. So 1 should be able to travel to 0, 3 should be able to travel to 0, 2 should be able to travel to 0, 4 should be able to travel to 0, and 5 should be able to travel to 0. We don't have to add some new connections. We just can change the direction of the one-way road. So in this example here, city 4 is already able to go to city 0, so we don't have to change that connection. But city 4 is going to 5, and 5 is not able to go to city 0 because um, it's there is 4 between 5 and 0, but this one-way road is taking city 4 to city 5. So what we have to do is change the direction. We'll change this direction so that city 5 people can go to city 4, and from there they can go to 0. So we have changed one direction, and similarly city 0 can go to 1. We have to change this direction as well. So we have changed two directions, and 1 is going to 3. We have to change this direction as well. This is already going to 3, and then 3 can go to 1, and from 1 they can go to 0. So in total we changed 3 directions. So the answer will be 3. So we have to return the number of changes we need to make. We'll create a two-way graph in this for this problem. For instance, let's take an example. We have city 0 and we have city 1. Let's for instance say city 0 is connected to city 1. When we are creating a graph, we'll create two entries from 0 to 1 and from 1 to 0. So if city 0 is connected to city 1, that means we have to change the direction because we are supposed to reach the 0, but this route is going from 0 to 1, so we have to change it. So what we will do is we'll create a tuple as a value. If anything is going from 0, we'll have a 1 in the tuple. If anything is coming back to 0, in that case we'll have 0 in the tuple. Let me show you how. So we'll initialize graph, and for connection, in connections, in each connection we have a starting point and an end point as well, is equal to connection. Now if not start in graph, if it's not in graph, then we have to initialize it. We'll write it like this. There is a shorter way to write it, but to keep it simple, I will write it like this: n comma 1. So if it's not in the graph, if the start city is not in the graph, we'll create a connection from city start to end, and we will also add 1 to it, because we will start from 0. So if start is connected to end, means we have to change the direction. Else we can do, if it's already in the graph, we can just append. So we can do is graph start dot append end comma 1, and similarly we will do it in the other direction as well. If not, end in graph end is equal to start, but in this situation we will have 0 here, because as I said, we'll start from 0, and if we are able to go from 0, if we are able to go back to 0, which is the start, we don't have to change direction. Zero. Now once we have created this graph, filled up this graph with all the directions, what we have to do, we'll use stack. We'll start at 0, as I already mentioned. So we'll initialize the stack, put 0 inside it, and also keep the count of cities that we have already visited and add 0 to it. Now we'll also have a variable changes made, and initialize it to 0. Now until the stack is not empty, we'll keep on going through the loop and pop each element, each city from the stack, from the top of the stack, and for each city we will check all the neighbors of this city in the graph. Initially, remember, this city is 0, initially 0, because we appended 0 over here. Now for neighbor in this graph city, so for all the neighbors in this graph city that we can visit, we have appended these neighbors here, like end comma 1 or start comma 0. What we will do is, if nay not in graph city, so we will check if this nay comma 0 is this end or like start, because we appended a city in the 0 index of the tuple. So we'll check if nay 0. Nay is the tuple here, because we are appending a tuple in the dictionary. So if neighbor 0 not in visited, if we have not visited it, only then what we will do is we will increment the changes. Now how will we increment the change? We will increment it using the first index of the tuple. So as I already mentioned, if we are starting from 0, if this is 0 and this is 1, means we have to change the direction. We can go from 0 to 1, but we are supposed to go from 1 to 0. So we have to change the direction, and it will increment it 1. But in that case, 0 is the end, the final destination, and we are starting from 1 and going to 0. We don't have to change the direction, so we'll append 0 to it, increment 0. I hope you understand this. And once we have done that, we will append it to stack to check its neighbors. We'll append this city in the stack to check its neighbors as well, and also add it to visited set. And that's it. And I think if we return the changes made, it should work. Thank you for watching this video. Please consider subscribing to my channel.